Hello everyone. Today we shall discuss about 8051 serial port programming in assembly and C. So whenever you are going to have a serial communication, it is important for us to know the baud rate. At what baud rate you are sending the data. So we have some standard baud rates here. So that is 110, 150, 300, 600, 1200, 2400, 4800, 9600 and 1,92,000. So these are some standard baud rates. To set this baud rate, we are using timer 1 in mode 2. Always we are using auto reload mode and we are using timer 1 only. So this is configured using the instruction move tmod hash 20h. So that is we discussed already in the previous session. So next we shall discuss about how to configure what value you have to put into the timers for getting the required baud rate. So as I said earlier, we are using always timer 1 for auto reload. So that means you have to load th1. So what value you have to load, that depends on the baud rate that you are choosing. So we know that first the oscillator frequency of 11.052 MHz is divided by 12. Why it is divided by 12 is 1 machine cycle is equivalent to 12 clock cycles that we already saw. So when you divide this 11.0592 by 12, you get 921.6 kilohertz. And next, if you divide this by further 32, so the UART is going to divide this by default 32. So what is this UART is? Universal asynchronous receiver and transmitter that is used for the serial communication and asynchronous communication. So you get, when you divide 921.6 kilohertz by 32, you get 28,800. So this value is taken as reference to calculate the TH1 value. So how to load the TH1 value is, you have to divide this 28,800. If you divide by 3, you are going to get 9,600. Now what you have to do is, you have to load your timer with -3 or FD. And similarly, when you divide this 28,800 by 6, you get 4,800. So in order to get this 4,800, you had to fill the th1 with -6 or fa in hex. And similarly, if you want 2,400, you had to divide this 28,800 by 12. Hence the th1 value is -12 or f4. Similarly, if you want 1,200, you have to divide this 28,800 by 24, you get -24. That value has to be loaded in decimal and E8 in hex. So next we shall discuss about how to load the values in your th1. As I discussed earlier, you have to divide 28,800 by the different values, so that you will get the required baud rate. If you want 9,600, you have to divide it by 3. That's why you will take -3 in th1 or fd in hex. Similarly, if you want 2,400, you have to divide it by 12. So that's why you will take -12. Similarly, if you want 1,200, it is 24. So that value has to be loaded into th1 using instruction move th1 hash, whatever the value that you get with minus sign after division. And next, SBUF register. What is this SBUF register is? It's a very important register for serial communication. So that whatever the data that you want to send will be put into SBUF first, and then it is transmitted bit by bit. Similarly, whatever the data that you receive from the line, serial communication line, is will be present in the SBUF. Later you will copy it into required registers. So now, for example, if I want to transmit data D, ASCII value D, first I have to put it in SBUF, then I need to transmit it. So similarly, if I want to transmit any data that is present in accumulator, I have to put it in SBUF first, and this is what is transmission. When you are going to have a receiving, SBUF holds the data byte of when it is received by the RxD line. RxD means receiver line. So the data that you receive will be present in SBUF, that you have to put it into the place where you want. It can be accumulator or it can be ports. Wherever you want, you can copy it and save it. So now we shall see what is SCON register is. SCON means serial control register. This is used for the setting of mode for serial communication. So it's an 8-bit register used to program the start and stop bit and data bits of data framing. So this is decides how much is the start bit, and how many bits you are using for communication. So SM0, SM1 are serial port mode specifiers. So 00 means mode 0, serial mode 0, 01 means serial mode 1, and 10 means serial mode 2, and 11 means it is serial mode 3. So that is how you are doing. And next, SM2 means it is for multiprocessor capability. You are not using this bit is always taken as 0 in our concern. Next is REN. REN means receive enable. Whenever you want to receive the data, this bit should be always enabled. So then only we will be able to receive. If you make it as 0, you will not be able to receive the data. So that is what is receive enable. This is always 1. TB8 and RB8, they are used for 9-bit data. If you are transmitting 9-bit data, you can use this, or else you should not use this. In our discussions, we are not going to use these 2 bits, and we are making these 2 bits as 0. Next, we shall take transmit interrupt flag. What is this transmit interrupt flag is? Whenever you want to send the data in serial communication, you will send the data in bit by bit. So you are going to send the data in bits, and once you are sending the data in bits, when you complete the 8-bit data, and when you send the stop bit, at the beginning of this stop bit, this flag goes high. So when this flag goes high, it indicates that transmission is complete. So now next you can send another character if you want. And similarly, whenever you are receiving the data, this RI remains 0 until you receive all the 8 bits. Once all the 8 bits are received, then only this bit goes to high to indicate that the receiving of all 8 bits is complete. This goes high when you are going to transmit the stop bit. So in transmit interrupt, the transmit interrupt flag is going to set at the beginning of stop bit, but here it is at the halfway through the stop bit, this bit goes high, and this 2 bits has to be cleared by software. Cleared by software means you should use an instruction called as clear TI and clear RI for further communication. If you want to transmit further data, and if you want to receive further data, you can you should clear this 2 bits, then only you will be able to transmit further characters, else you will not be able to do that. So here in detail we shall discuss about what is this serial mode modes are. So 00 means serial mode 0, and 01 means it is your serial mode 1, 10 means serial mode 2, and 11 means serial mode 3. So now you can see that we are using 8-bit data, 1 stop and 1 start bit. We already discussed this in the previous session, that in the data framing we are using 8-bit data with one start and one stop bit. Hence we are using this always as 0 and 1. We are using these two always as 0. And next is SM2, that is called as multiprocessor. We are leaving it, we are making this bit as always 0. And next receive enable, whenever you want to receive the data you should mandatorily make this bit as 1. So that is 1. So next TB8 means we are not using TB8 and RB8 because we are going for 8-bit data. Whenever you are going for 9-bit data, then you have to enable this. So hence I will make these two as 0. So the next left is your TI and RI, that is also made as 0. So now this is how you have to make it as your particular coding. Next is TB8 and RB8. RAN is as I said it is 1, TB8 RB8 is 0. We are not using 9 bits, we are using only 8-bit data, that's why you should make it as 0. Next TI and RI, so already discussed. This will be set to 1 when transmission is complete or receiving is complete. So what it says is, when 8051 finishes the transfer of 8-bit character, when all the 8 bits are transmitted, then this flag goes high to indicate that transmission is complete. So similarly, whenever you are using it in receiver mode 8051, so whenever it receives all the 8 bits, it indicates that RI is equal to 1 means receiving is complete, and you have to pick the data which is present in SBUF and save it before it is lost. If you keep it as it is, if you don't copy somewhere else, what happens is other data will come and override that previous data. So both TI and RI should be cleared by software. You have to clear it. Software means whatever the program that you are writing in your application, that is called as software. So you have to use in your program clear TI and clear RI if you want to continue your communication. For example, if I want to transmit ECE, E means it is a first character. So when you complete the transmission of E, that is first character, the TI goes high. So now what you have to do is, in order to transmit C, what you have to do is you have to make this TI is equal to 0. If you don't make this TI is equal to 0, you will not be able to transmit character C. Similarly, when character C is transmitted, the TI goes high. So again, if you want to transmit another ECE, another E you want to transmit, at that time you have to make this TI as 0. If you don't make this TI as 0, you will not be able to transmit to further characters. Similarly, receiver also. If you want to receive ECE, when you receive E, you have to make again RI is equal to 0, so that you will be able to receive C. When you receive C, RI goes high. Again, you have to make this as 0 to receive another E. This is how your TI and RI works. So now we shall see how to configure this SCON register. This is almost always common, so that it is there will be no change in this. As I said earlier, we are going for mode 1. So that is this bit will be 0 and this bit will be 1. And next SM2 is always 0. You can see that SM2 is always 0 because we are not using that. Okay. And next you are using REN is 1. REN is 1 means it is receive enable. Receive enable, whenever you want to receive the data, you have to make this bit as high. If you don't make this bit as high, you will not be able to receive the data. So that's why this is always 1. SM0, SM1 is 0, 1 always. SM2 is 0 always. REN is 1 always. And TB8 is 0 always. In our discussion, we are not going to use this particular 9-bit data. Okay, so we are using only for 8-bit data, and RB8 is received bit 8. So this is also not used. This is also 0. And this TI and RI should be at the initial stage, it should be 0. If you want to transmit, start a transmission, you should have this as 0. So this becomes 0 in this is 0, 0, 0 is nothing but it is 0, and this 0, 1, 0 1 means it is 5. So this is loaded into SCON. So this is loaded into your SCON. So this is how you have to program your SCON register. Always you can see that SCON is always 50H, always 50H, and you are using timer 1 in mode 2 for your deciding the baud rate. And how to do that baud rate is, calculate that baud rate is, divide 28,800 by required baud rate, then you will get the count, and you write it with a minus sign, or you can take the uh, 2's complement of that in hex. So this is how you can use your SCON register as well as decide your baud rates. Thank you. Here are some review questions. Explain the value to be loaded into TH1 for various baud rates. For various baud rates, what are the TH1 values? You should be calculating it. Already we discussed. Explain the bit pattern of SCON register, SM0, SM1, SM2, and REN, TB8, RB8, TI, RI should be explained. And explain the role of SBUF. What is the role of SBUF? So that you have to explain why it is used, means you know that already we discussed in the session. Thank you.